when it comes to mesh rendering, if you want to be a good modeler and a good environment artist or asset artist or whatever you do, you need to understand how it renders things. Well, Unreal, first of all, Unreal's forward rendering is not the third rendering. It's not like Crysis or Skyrim or anything like that. That's the third rendering. But Unreal does forward rendering. So it's quite weak with dynamic lights, for example. But on the plus side, you have light maps and you can get some more details basically in the lighting. And they can handle shadows better, etc. So basically how it works is when you render something in a game, I have a simple test scene here with a landscape and 4 teapots. These are all the same. This one, however, has 2 materials. So it has material A on the body and material B on these 2 parts. But it's still the same mesh. So what happens when a game renders this? It's unlike what, for example, happens in Max or Maya when you render a picture, when you render an image. It doesn't go through like pixel per pixel or line per line or block per block. You know, it doesn't build up this line per line or it doesn't do little blocks and renders them out. No, it goes through object per object. That's how it renders scenes. So when it's rendering this right now, what the computer is doing is it's pretty much rendering this image 100 times or so. And that gives me 100 frames per second. So it basically has to render a picture 100 times a second, and then I have 100 frames per second, obviously. And each time it renders each one of those pictures, it has to render object per object individually. It doesn't render the whole thing, it renders it piece per piece. So what happens here is, if you were to look at what it does, is it would start like this. It starts gray, and then it brings in the first mesh. So it will ask the memory, the processor will ask the memory, or the GPU processor will ask the memory, you know, can you please send me the first thing? And then the GPU answers, okay, here's the first mesh. It's called landscape. It has 16,000 triangles or whatever it has. And these are all the position of all the vertices. These are all the UV coordinates. This is all the information you need to display it. And then the GPU will do this. Okay, then we're done with that. I've rendered that. And then it will say, okay, I'm done with this. Can you now please send me the next piece? And then it will be answered with, okay, this is the first teapot. This is this many triangles. And the vertices are on these positions. There's vertex colors on these vertices. And these are the UV coordinates. And these are light map coordinates. So it sends all the information it needs. And then the GPU does this. They get a second object. It will ask again, can you please send me the next part? Okay, here is the next part. Can you please send me the next object? Okay, let's render the next object. Can you then send me the next object? Okay, but the next object is made up of 2 different materials. So in that case, the engine first has to render material A, and then B, etc. So that's how it goes through a scene. It doesn't render the whole scene at once. It renders it mesh per mesh for every and material per material. So if a mesh has 2 different materials, it has to render that in 2 steps. It first has to render everything with material A, and then everything with material B, and then it moves on to the next object. So it does this hundreds or even 1,000 times for every single image, and since you have maybe 30, 40, 50 frames per second, it has to do that 50 times the things in view. So if you can see 2,000 objects in view, it has to do that 50 times 2,000. And that's a very nice big number. So it has to do that 100 times. It has to render 100,000 objects per second in that case. So computers are really good at that though. It's what we focused our 3D cards and all the GPUs on doing exactly that, on just pushing polygons and pushing objects. And that's exactly the thing. We got up to a point where it's 2013 and the Polycount really isn't that big of a deal anymore. I think every time I talk to students or people who are new to 3D, every time they're very obsessed, in my opinion, by, you know, what's the maximum Polycount I can use? Well, there isn't really any. That's it. That's the real answer. There is no maximum Polycount. It's not the Polycount that's really going to drag down your performance. It's a lot of other things. You know, the story in 1995, you could perhaps say, what's the Polycount? And perhaps it would have had a real impact, yes. But by, you know, in today's age, there's so many different things that have such a profound impact on performance that Polycount is really the least of your worries. Of course, polygons still have an impact. And if you have billions of them, you're going to slow down the computer. but in general, it's really not the biggest of your problems, not the biggest of your concerns. And I can show you what happens. I have one level here, which is this. And I can play that. So here we are playing it. What I did was I took a teapot, and each of these teapots is like 16,000 triangles each or something in that direction. I lined them up all one by one, and I positioned the camera behind them so you can see all of them. Now if I type start FPS, see frame rate, and I have about 100 frames per second. So this takes me 100 frames per second to render. If I type start, let's do this, start T3D D3D 9 RHI. So if I type that, stat D3D from Direct3D 9 from DirectX 9 RHI. If you're using DirectX 11, you have to replace 9 with 11. Then I can see the number of triangles. And now you can see here, it says triangles drawn is 7,155,324. So this is 7.1 million triangles, and it's rendering at 100 FPS. Okay, so 7 million triangles, 100 FPS. Now let's take the other one. Let's do that. And here we have a similar scene. It's the exact same camera angle, except instead of teapots, I have a bunch of planes. And each of these planes is, I don't know exactly how much anymore, but very, very little. Each of these planes is just 32 triangles. It's just 32 triangles. So the polycount of this is immensely low. And in fact, the polycount is just 42,000. So this is 42,000 triangles rendering at 36 frames per second. So we have 7.1 million rendering at 100 frames per second. And we have the amazing 42,000 triangles running at just 36 frames per second. So the 42,000 triangles I have here run 1.5 times, or what is it, a lot slower than 7.1 million. And why is that? And this really illustrates the point as well. In the year 2013, triangles really aren't everything anymore. It's just one out of the many things that you have to keep in mind. And in fact, there's a lot of things out there that are a lot worse than your polycount. It's really not the biggest thing anymore to keep in mind. What is much worse, for example, is the draw calls. And that's why there is such a gigantic difference here in this scene. If you look at draw primitive calls right above triangles drawn, then this is 20,100 draw primitive calls. It's 20,000 draw calls. We compare with the other one, and this is the difference. We now go back to the first one. With our teapots, then it's only 538 draw calls. So the other one is 19,500 draw calls heavier than this. And that's where the difference in FPS is. Actually, now it's running 120 FPS even. So it got even better. So that's the difference in FPS. So it doesn't really matter for the engine that the polycount is so much higher. What really matters for the engine is that the draw calls are so much lower. And what is a draw call? Well, a draw call is every time the engine has to stop and ask for the next object. So every time the engine does this, that is a draw call. So every time the engine does this is one draw call, 2 draw calls, 3 draw calls, 4 draw calls, 5 draw calls, 6 draw calls. So every separate object and every material on every object is another draw call. And it's not really the problem rendering a lot of polygons. The engine has no problem, and this actually goes for most engines, not just Unreal. This is pretty universal. The hardware in general, a computer in general, doesn't really have a problem pushing through a lot of polygons. In fact, I can probably get 2 million polygons running totally smooth on an iPhone 4S, for example. You know, we can take a modern mobile device and you can easily get that to render several millions of polygons if you do it correctly. And in the same way, you can make a PC game on a super powerful computer and have it render horribly with just a few 10,000 polygons. It's just how you do it. So for the PC, it's not really that big of a deal to just render all of these polygons. So sure, it's a lot of polygons in a single object, but once those polygons arrive, once the draw call has been answered by the memory and by wherever it's coming from, once the information arrives at the GPU, that GPU has very little, it will take him very little effort to just push through tens of thousands of polygons. So once the information arrives, it's really good at just massively calculating all of it at the same time. What it's not very good at, however, is waiting in between each step. So each time it's ready with an object, like it is now, it has to stop. And now it has to phone home, it has to call, it has to ask for the next object arrived, and then the information on the next object arrived, and then it can continue rendering all of that. So once the information of this arrives, it can just push through all of these polygons. And then it doesn't really matter if this is 10 polygons or 5,000 polygons. Once the information arrives, it can just crash right through, and it can do so very fast and very efficiently. But again, what it's slow at is the waiting between each step. Each time it's done with an object, it has to wait. And even if it has to wait only half a millisecond, even if it has to wait only 1/2000th of a second, that does add up if you have to do this 100 times a second, right? Because you have to do this. If you, like we calculated earlier, if you have 50 frames per second and you have like 2000 objects per scene, well, that's a hell of a lot. Then that's 100,000 times a second. So the slightest delay adds up a lot. And each time it renders the next object, there is a very slight delay which has a profound impact on performance. That's the draw call. When I was working on PlayStation 2 at Guerrilla Games, I was told, for example, and again, this is really depends on computer to computer, on device to device. So PlayStation 2 is obviously not a modern computer, and it wasn't obviously Unreal Engine 3, but the general idea remains the same. What they told me back then, that was 2003, 2004, is that if you make a cube, it doesn't matter how many polygons it has. If you make a cube that's 40 polygons, that cube will take the same amount to render, same time to render, as a 1000 triangle cube. Because the time it takes the engine to wait, the time it takes to have the draw call answered, that time, that's what really matters. And once the polygons arrive, it will make barely any difference between rendering 10 polygons or rendering 1,000. It's the delay of the waiting, that's where the problem was. So in the same case, you could say that if I have a teapot here, I don't know how big this is. Well, this teapot, for example, is 992 triangles. In that sense, you could say that this teapot, and here we have a plane, this will render almost the same, especially when this has two different materials. There's one material right now, but if I would add two materials here, this would cost the same amount as this with 2000 triangles. And that's the thing. So the polycount isn't really the biggest thing anymore. What really counts is the draw calls, but it's also the dynamic lighting on top, how that impacts the scene. It's also dynamic shadows. This is dynamic shadow, how that impacts the scene. It's things like sorting things. If you have a lot of smoke going over the screen, the engine has to do a lot of sorting on the translucent pixels. That's heavy. You have a lot of those kind of things. That's where the performance is. But just pure raw polycount pushing, that you can do on pretty much any device out there in the year 2013. You can easily just push through 1 million polygons really fast and efficiently. So I quickly give you the conclusion on that using these two examples here. See, here we have a lot of teapots. They're all very high poly. So this is 7 million polygons you're looking at. But there's actually very few teapots. There's only 500 or so of these. Whereas if you look at this, there's also only, this is 1,000, I think there's 1,000 of these planes. But each of these planes is only 32 triangles, but each of them has 16 different materials on it. So for each of the materials, it has to stop before it has to move on to the next one. Render, stop, render, stop, render, stop. Extremely inefficient here, because it can pretty much only render 2 triangles at a time, and then it has to stop. 2 triangles, stop, 2 triangles, stop, 2 triangles, stop. And that's what makes this incredibly slow to render, because it can do almost nothing. It's more stopping than actually working. And that's the slowness in this scene. That's why this is immensely inefficient. I can give you a very brief overview on forward rendering as well. So if you look at this scene, something pretty to go on, Unreal is forward rendering, meaning that it will just go forward. It will just go through the process and just do it nicely in order pretty much. So it will just render the objects as it needs them. It builds up the scene like that. If there is dynamic light on top, and there is, this is dynamic light, it will re-render the objects again. So any mesh hit by dynamic light will be rendered again. So if this mesh is, I don't know what it is now, but let's say this is 10,000 triangles for the teapot. Well, it will render it once, that's 10,000 triangles. Now it will render it a second time, you're at 20,000 triangles, and it's 2 draw calls. And then, so it basically renders everything that the dynamic light hits will be rendered again for the dynamic light calculations. And that's why it's forward rendering. If you were to have deferred rendering, which is what Crysis does, or Skyrim or so, whatever, it would wait with rendering the dynamic light until at the end of it. That's why it's deferring the rendering. It's deferring the lighting until the end. And by doing so, it's a lot faster to render dynamic light. Unreal is very slow with it. You would never be able to make Skyrim and Unreal size of the world aside. You wouldn't be able to do it because of the lighting either. Because Unreal has to render the object, then it has to render the dynamic light on top of it. Then it has to render the next object, then it has to render dynamic light on top of that object. And it goes through in a very forward, very simple way. The third rendering will just render everything in the scene, and then it will say, okay, now I'm going to render the lighting on top of everything after I'm done with all the geometry. And it will just render the lighting on top of every object all at once in a single pass. And that makes it a lot faster. However, that also means you don't have light maps. That also means you don't have real good shadows. That means you will have to rely entirely on dynamic shadows like these. Whereas Unreal can light map things, and if you have light maps, you can get a lot better shadows. You can have really nice fading shadows. You can have nice bounced lighting. You can do things that are right now today still quite hard to do if you do everything dynamically, because the third rendering is entirely dynamically driven. So for those reasons, I mean, there are specific advantages as well. You would never be able to do Skyrim in Unreal, but you would be able to get better shadows in Unreal than you can get in Skyrim, for example. So that's also the third rendering and forward rendering in a nutshell. If we return to the draw call issue for a moment again, I can show you a mechanical again. So this is the iOS version. And the problem is, so every single object you add is one draw call. Unreal is also unable to batch render things. I believe Unity, for example, is, and it's not impossible to add it to Unreal. I actually did it, or at least a program did it on a game I once worked on. And what we did over there was we automatically, regardlessly of the object was separate or not, it would take all the polygons that share the same material in view and render all of those at once. And then it would take all the polygons with the next shared material and render all of those at once. By default, Unreal doesn't do that though. By default, Unreal will really do this. It takes this mesh, then it takes that mesh, then it takes that mesh, that mesh, that mesh. It really renders it piece per piece as it goes through. So obviously, if you have a lot of pieces in here, it's gonna get slow. See, because it really has to go through step by step. And in a way, it's almost better if the pieces are really high poly and big, because at least it's worth it. Like I said earlier, if you only have to render 2 triangles, it's kind of a waste of time. You know, you kind of have to wait a long time and then you only get to render 2 polygons. It's not very efficient. So what we have in the iOS version here is we try to do some aggressive merging. The rocks, unfortunately, we were not able to merge because they're too high poly. So if we start to say, okay, you know, I'm going to make a unique mesh out of all of this, instead of having all the separate ones, I'm going to just combine all of this together. Could have done that, but the problem is that all of this is quite a high poly count, and it's about 1 megabyte, I believe, for every 10,000 triangles you have. It's not a very hard number, it's a bit less actually. But let's say it's about 1 megabyte for every 10,000 triangles. Well, if this is 10,000 triangles, then this is 1 megabyte of 3D data if I merge this together. And that's also the thing, it's a common misconception is the following. People say, well, aren't meshes instanced? Yes, they are, but they are instanced in the memory. They're not instanced on the CPU. And that's the very big difference. If you look here, you can see this is the rock that's used, for example. That rock is 61 kilobytes. So it's 61 kilobytes at 1,000 triangles. So if you have that rock in here, and I can add it, for example, here again. This is not instance. The engine is still rendering this twice. However, in the way it's instance is it only loads it in the memory once. And that's how the instancing in Unreal works. So of all these meshes, if you use this mesh 100 times in a level, it's not going to do 100 times 61 kilobytes. No, it's only going to load it once. So there's only a footprint of 61 kilobytes in the memory. But every time, so that's the instancing, that's memory instancing. It only loads it once, but then it renders it several times. But it still has to render it several times, that's the thing. So it doesn't really matter if it's loaded only once in the memory, that's nice. But at the end of the day, it still has to render this first, then that, etc. So yeah, if you were to want to combine this, you would get too many polygons. It would the size would go up, especially for a mobile game. So we weren't able to do that. What we were able to do, however, is combine all the cubes, because the cubes we have here, they're very low poly, so they were very easy to combine. All of this we combined, you can see we placed them in the editor, and then you export that as one big mesh and you combine them in Max. And this is much more draw call efficient. See, and then here the next part starts. So we made big unique chunks out of it, and we made sure that they were quite low poly and optimized. For example, this is only 120 kilobytes for this part, which is very doable. And also, if you double click it, you can see collision is disabled on it, as discussed earlier, to save a little bit of size. I can also show you how we actually do this, which ties into our workflow thing of bringing editor stuff back and forth. What you can do when you want to merge things, because there is not a real easy merge tool in the editor. Epic did add this tool at some point, but it's so beyond horrible that it's completely unuseful. There's one tool here somewhere that says merge it using Simplygon or something like that. I don't even know where it went. It might not be in this version of the editor. But that's completely unuseful because it actually modifies UV coordinates, it makes really blurry textures, it's completely unuseful. So the only real way I found to reduce draw calls and merge things together is doing it manually in Max or Maya. So we would place the objects in here. For example, let's merge these two. We say we want to make this one unique mesh. I would select that in the level. Then I would right click that, do export as FBX, so I can actually export everything back. And that's also the thing with the content browser. Everything you import in here remembers both the Unreal model and the Unreal texture, like the converted one, and it remembers the source one. So if you import a TGA texture, it will remember both the DDS file that Unreal makes internally, and it will remember your original TGA file. So you're able to export things again as well, and they're uncompressed. You're basically able to export the original files again just by right clicking it and do export the file. Or if it's placed in level, right click it in level, export FBX. Okay, let's try to place it somewhere. So that has been exported. Now I can go back to Max and I can drag it in. So I made an FBX file out of it. You can see it, merge F export FBX, and I can import that one. I get an import window. Again, you might have to mess with the scale factor, not sure. Let's just try what happens. And see, now we have imported that, and it actually took over the position as well. So the positions and everything should be the same as it is in Unreal. And now you can merge this together. So if I touched it, and when you import FBX, you should clean it up a bit. So what I usually tend to do is I make it edit poly. I quickly select all the vertices, weld all the vertices together, because they are often unwelded because of how Unreal splits things up, because of the smoothing and such. And then I quickly smooth it back together like that. So it's a bit restored now. And then also you have to be careful with the light mapping, because the light mapping is now overlapping, because it's basically two different meshes. So if you have a look at the light map, you see this, it's all overlapping, so I'm going to do tools and pack them back together. There we're going to have that. It got a bit broken up, so I'm going to try to undo it and first weld the vertices like that. And that's a better result. Right, so I'm just ending up with this. I just pack the existing UV corners. I don't re-flatten, I don't re-UV it, I just repack it. So it gets distributed evenly again over the 0 to 1 space. And that's it. And then we can export this. I'm naming it. Then one thing though, when you export something like this, when you export a mesh that has to actually fit a specific location, you don't want to move it to 0, 0. You actually want to leave it in position, because this position corresponds to this position. So I'm actually going to leave it in place. So in the export script, for example, I take away use object pivot as origin instead. And there we are. So I quickly re-exported that. Then same thing. Once you've imported the mesh, you place it, but you move it to 0, 0, 0, and by moving to 0, 0, 0, it will line up exactly with where it came from. And this is actually a technique that I use very, very frequently. So I can show you this also, and this is now done for optimization purposes, making it one big mesh. But I don't just use it for optimization, I also use it for actually building things. So for example, you have this landscape here. You have 3 teapots, or for example, let's take the road. It's even better to work with the road. It's a more illustrating example. So you have a landscape here with a road. Let's say you want to do something special. You want to have a special piece of road here. You want to do something weird. And you're not going to be able to manage to do that with modular meshes. So whatever we have in mind, we have some weird shape. We'll never manage to do that with modular meshes. However, we don't want to take away your modular meshes over here either. So what we can do then is make a unique mesh that lines up exactly with this one. So what I do now is I'm going to export a couple of meshes from here to max again. So that in max I have a reference, I have a starting point, I know where to work from. So we'll do that. Again, it's the same system here. Right click, export as FBX. There we go. In max. Import that. Again, make sure you check it's indeed scale factor 1 is correct. Import. And now we have the road that I had in Unreal back in max, purely as a reference object. I'm gonna group it together. It doesn't have any texture, it's not really important. It's just for me to know the position and the scale and everything I need to know. And now what I could do is, for example, I could say, okay, fine. Let's take something that we wanna add it to. So for example, let's take let's just take the straight road. Now I believe it's twice the size in Unreal. I made it draw scale 2, as you can see here at the bottom. So I'm gonna make this one size 200 over here. And then I can just snap it to the one I exported from Unreal, and I can do weird stuff with it. So for example, I can distort it a bit. I can do, for example, this, and then let's say we just keep on building. I'm going to do this very quickly just to get the point across how you would build something that's unique to the level based on exporting something from the level. Okay, so we have a special piece of road, it connects to the previous one, and then we export that. Again, when you export it, make sure you turn off use object pivot as origin. It actually has to remain, it should not move back to 0, 0 while it export actually has to remain exactly where it is, because this is also aligned to 0, 0 as it is in Unreal. So in order to keep that relative to each other, it should not move back to 0, 0. And then in Unreal, we can import that. And then when I place this in the level, and I bring up the properties and I place the position on 0, 0, 0, it lines up exactly with the already existing bit. So I've now made a unique modular piece, not a modular, made a unique piece of road that aligns exactly with my existing modular pieces of road. And in this same way I make caves, so make anything that's unique to the level is done this way. So the pivot point is all the way there, mesh is here. And that has been my long approach of handling these kind of cases. It's also a case, for example, where you use some brushes to block something out, or you just place some quick meshes to block something out in here, and then you would export it to Max or Maya and actually properly model it there based on your blocked out shapes. So you can do all kinds of things like that. And then before we move on to materials and we can finally close off all the 3D things, one word about package organization. This is also gonna bring in some textures here, combine the texture part. What I tend to do, and what I've done until so far, because we're just discussing all the 3D parts and all the properties are important. So what I've done so far is just import everything in one big package. I made a package, your new package name, not the most brilliant name either, and I just import everything as it is. What would be a better way to go would be as I've done with the proper examples that I have here. So these are the two packages that you have as well. I'll fully load them. Sometimes it doesn't show everything that's really in there, so remember to fully load things before using them. This is how I would tend to do things nowadays. So I would tend to make two packages that belong together, one containing the materials and the meshes, and the other one containing just the texture. So I have a separate package for purely the textures. And the reason why I tend to do that is because the materials and the meshes tend to be the smallest in size. Now the meshes is not necessarily very small, kind of depends of course on your game and on how high poly everything is, but meshes tend to be quite small, whereas textures tend to be really big. So since I often work remotely, and since I often have to send through a lot of packages and receive a lot of packages over the internet, it helps a lot if the packages that I receive aren't gigantic in size. So for those reasons I split it up. I put the very big stuff, everything that's really big in size, in a separate package called textures, and then I put everything else in its own asset package. And the thought here is that when people work on the packages, so when the environment artist is working on stuff, he's not going to have to update the texture package every time. He's probably just going to import his texture, and then from there on he's just going to add new materials and tweak the materials and add new meshes in this one. So the thought is that every time he does stuff, it happens mostly to the assets package, not to the texture package. Therefore, it's not the texture package that has to be sent through over the internet all the time. You know, if you were to combine these two in a single package, then every time you made even the slightest tweak to material, you would also have to upload 300 megabytes or something of textures. And that wouldn't be very good. So that's why I'm splitting it up. I also made groups here, materials, SM, and textures, and that's it. Again, name shouldn't be longer than 30 characters. I think this is, 25 or so. It's probably just under. And no non-standard characters, no spaces, underscores only, exact, etc. Also, one thing that might be nice to know is you can make subgroups, which is not very obvious from the interface, but you can actually do this. So if I import one in my test package here, I'll import a low rock. Obviously, if you just type a name here, like meshes in the grouping, it will create you a group called meshes. That rock is now in there. Everything else is in the main, in the root of the package. But I can also import something in a folder in a group of a group. So if I take low lot 2 then, for example, I can do meshes dot another group. So if you type dot something and then type the next one, you can create a group in a group. So see, now I have another level beneath that. And technically you can keep on going. So if I just take one other mesh here. So now I have a group in a group in a group, etc. So you can further organize your packages in that way. I usually, again, don't tend to do that. I rather keep things simple. So I just stick to this setup. Also, the folders you're looking at here in here, you can't actually make the folders in the content browser. So you can't actually make things like these. You make those in Windows, and you have to, before you can make them, you have to shut down the editor. So if you want to make your own folders, you have to shut down the editor and then go to Windows, to the File Explorer, go to where you have the UDK installed, UDK game, content. This is where all the packages are, as you can see. If I now were to make a new folder in here, I made a new folder, which you can call anything, again, no spaces, etc., but you can call it otherwise anything, call it anything literally. Then I could move my packages in there. And you know, in there you could then make another folder, just like they've done here in Maps. You open Maps folder, you get that. So you can make your own folders in here and then move these freely around, as long as you don't move any of these files outside of the content directory. You can move them however you want within. You can make any folder you want, do whatever you want, but as long as you don't move it outside. And also, if you move any file or you make any change to this, then obviously close down the editor. If you want to share files with someone else on the team or whoever, just send them the level. This is a level, UDK is level, UPK is a package. Just send them the necessary files that they need. Just put this on Dropbox, zip it together, etc. And then they can put it wherever they want in content. Unreal doesn't remember the exact location. So Unreal will not remember that this one is in UI, UT3 in content. You might just as well move this one to the content root directory, for example, and it will still work.